In this video, we're going to look at some factoring techniques for polynomials, in particular binomials, trinomials, generally one variable. We'll look at some with two variables. So as I go through each problem here, I'll kind of just talk over the procedure. So the first one's a binomial, two terms. And generally when we're factoring, especially if you're factoring a binomial, which is a polynomial of two terms, or a trinomial, and polynomial of three terms, you always want to look to see if you have a common factor. Okay, so for this one here, we have 3x to the fourth minus 12x to the third. You can see that 3 divides both terms, and the first term has a x to the fourth, and the second one has x to the third. So they have an x to the third in common. So I could actually factor, since 3 goes into 12, I can actually factor a 3 x to the third. So if I bring a factor of 3x to the third out, that's equivalent to dividing the binomial by 3x to the third. So what do we have left? Okay, if I take out a 3x to the third, well, the first one is going to have an x. If I take x to the third out and a 3x to the third, that'll leave me with a minus 4. And let's see, can I factor that again? Sometimes you'll have a difference of squares and so forth. But x and minus 4 have nothing in common other than a 1, and that would do us any good. So that's it for this one. This is your factorization, okay? You always want to make sure it's factored completely. So you apply all these techniques I'm going through here. So you can always check it. If you multiply 3x to the third times x, that gives me 3x to the fourth. And then 3x to the third times a minus 4, will give me a minus 12x to the third. So this one is a complete factorization. Okay, so before I go to the next one, just want to point out that you'll be using factoring methods when you solve equations, say polynomial equations. Sometimes you'll be called upon to factor. Reducing a rational expression will involve factoring, the same thing as it's addition, subtraction, and so forth of expressions. Sometimes even in trigonometry you use factoring. Okay, simplifying a trig expression will involve some factoring in some cases. And there's other types of problems that involve factoring, but here's just the straight techniques for factoring. So let's clear this. Let's go to the next one. Okay, the second one is also a binomial, has two terms. Okay, so what do we have? First, look to see if you have anything in common. We would look for a common factor that we can factor out. So this is equals here. So here I have x to the fourth. This term has x squared and y to the second. So you notice that they have x in common, and more than that, they have an x squared in common. So I can take an x out of this. So I just put x squared out here. And then what's left? Okay, if I take an x squared from x to the fourth, that leaves me with x squared. Take this x squared out, that'll leave me with a minus y squared. Okay, so you can see if I multiply x squared times x squared, I get x to the fourth, and x squared times a minus y to the second is minus x squared y squared. But here, in this particular case, here I have a difference of two squares. The first term is a perfect square, and so is the second term. So in this case, I use the formula for difference of squares. Anytime you have a difference of squares, you can factor that into the difference of the square roots and the sum of the square roots. So that means to complete the factorization, I could bring down the x squared, and then x squared minus y to the second. Again, I can factor that as a difference of the square roots and the sum of the square roots. So the square root of x squared is x. Square root of y squared is y. So again, anytime you have the difference of two squares, it's always going to factor into the sum and difference, or the difference and the sum of the square roots. Okay, so again, if you multiply this, x times x is x squared, minus y times y is minus y squared, and then if I multiply these here, that's minus xy, and these over here is xy. Those cancel out, so I get back the difference of the squares, x squared minus y squared. So this is the complete factorization. Okay, let's clear this. Go to the next one. Now here I have what is called a trinomial. It has three terms. So again, always look for a common factor. So notice every term has an x in it. X to the third, x to the second, x to the first. So that means I can factor out an x from the three terms. Notice that 2 goes into minus 14. It also goes into 12. So I can factor out a 2 from each term along with an x. So what's left? Okay, so I put parentheses here. I'm left here with an x squared. Minus 7 x plus 6. Okay, and then you can check that part of the factorization by just multiplying it out in your head. 2x times x squared is 2x to the third. 2x times a minus 7x is a minus 14x squared. That checks out. And 2x times 6 is 12x. Now the problem is, can I factor this trinomial further? Okay, so the way we do that is bring down the 2x. That stays out in front. Okay, so if we can factor out this trinomial, that means we can break it down, factor it down into two binomials, where the first terms here in the parentheses will be factors of x squared. So the only thing we have for x squared is x times x. X times x is x squared. And then the other thing we look at is if this third term is negative, then one sign here in the parentheses will be positive, the other one is negative, or negative and a positive. Okay. If this third term is negative or has a minus there, then one will be negative, the other one will be positive. So you have a minus here and a plus here, or a plus and a minus. Okay. So in this case, it's a plus. So if it's a plus, the signs here should be the same. Okay. So first we look to see if the third term is positive, then both signs are going to be whatever the middle term is, which is minus. So this will be minus and a minus. Okay, had this been a plus and this a plus, then both would be pluses. If this is negative or minus, then we have opposite signs here. Now we want to find the factors of 6. So we can put a 1 and a 6 there, or a 6 and a 1 there, a 2 and a 3, or a 3 and a 2, so that when you multiply it back out, you get this. Okay, so we can try 1 and 6, 3 and 2. But the one that's going to work is going to be the 1 and the 6, or the 6 and the 1. So it'll work if I put a 1 or minus 1 and a minus 6, or it could be a minus 6 and a minus 1. Because you can see x times x is x squared. Minus 6 times minus 1 is plus 6. That checks out. And then you check that middle term. So we multiply this out. Minus 1 times x is minus x. Minus 6 times x is minus 6x. Minus 1x and minus 6s is minus 7x. So this is a complete factorization. Okay. So now let's clear this and go to the next one. Now the next one has a polynomial of two variables, x and y, and this one has 4 terms. Okay, so if you have a binomial with just one variable, then again you have the common factor method, and then you look to see if you have difference of squares. Okay, or as you'll see in the next examples, you could have difference of cubes also. We'll consider that next. If you have a trinomial, 3 terms, then again you look for the common factor, and then you try to factor it the way I did a while ago. Sometimes that method is called the trial and error method. Okay, now if you have 4 terms or more, you try to group these in a way where they can be factored. Okay, if you can combine anything, you can combine. But you notice this is an x squared, this is xy term, this is an x by itself, and this is y. So I can't combine any of these. I can't add them up. So what I do is I group them. Here I'm just going to leave them the way they are. So I'm going to look at, you put them in groups. So I'm going to put the first two together and the last 2 together. Sometimes you have to switch them around so you get something that works. So from the first 2 terms, I have an x squared and an xy. So they have an x in common. So I'm going to take out the x from those 2. So take out an x from the first 2. That'll leave me with an x for this one and a plus y. Okay, so the last 2 terms are x plus y rather. So I'm just going to leave these the way they are, and let's put this a plus, and then I'm going to put x plus y. And then I'm going to put this in parentheses so you can see what I'm doing here. Okay, so I got x plus y. But notice I have an x plus y right here also. So I can use the common factor method. Remember the coefficient, if there's not a number in front of the variable or the parentheses, it's always understood to be a 1. So you can put a 1 here if you want. It doesn't change it. So now you got an x plus y and an x plus y. So let's factor out from those 2 terms. So kind of what I was doing up here in the first 2, actually the first 3, taking out the common factor. So here the common factor is x plus y. So bring out the x plus y. Okay, put parentheses here. Don't forget your parentheses. Okay, so what's left? If you bring this out, and again, put parentheses, because it's being multiplied now, common factor. So what's left if I take out the x plus y? Well, I'm going to have x plus 1. There it is. So this is the factorization. Okay. See, notice, again, here, even though I have parentheses here and parentheses here, this is not factored out because notice those 2 are connected with a plus. So it has to be a time. This is a times here. Okay, that's what factoring is. You have to express what you've got in terms of a product, strictly a product, for it to be factored. Okay, so that's the factorization. Let's clear this. Now we looked at the binomials. Sometimes you can have difference of squares. You can use common factor. Sometimes you got to have a difference of cubes. Okay, so this is actually your formula for difference of cubes. And I'll look at this formula in more detail in some other problems. But here's the way it works. If you have a difference of cubes, okay, they have x to the third and y to the third. That's difference of cubes. Then this is going to factor into, the first factor will always be the difference of the cube roots. Okay, so the cube root of x to the third is x. The cube root of y to the third is y. That's always going to be the first factor. Anytime you have a difference of cubes, the first factor will always be the difference of the cube roots. Okay, and then the second factor will always be the square of whatever you have here, the first term, so that would be an x squared. And then the sign will always be opposite of whatever you have here. You have a minus there, so that'll be a plus. And then the product of these 2, x and y. So that gets multiplied, xy. plus the second term squared. That's the y, so you square it. Okay, so now if you would multiply this out, x times x squared, x times xy, x times y to the second, and then minus y times x squared, minus y times xy, and then minus y times y to the second, and then combine your terms, you'll get this answer over here. That's how you can check it. But this is the factored form for this particular problem. Now sometimes you might have a common factor. Take out the common factor and then you look at the difference. If it's a difference of cubes, and you apply this formula again. So let's clear this. And then the last one that I have is very similar to this one, except it's a sum of two cubes. X to the third plus y to the third. So this is always going to work when you have two terms that are added that are cubes. So it works similar to the number 5. So this is going to equal to, okay, no common factor here. We got x and y here, so nothing's common. So if you have a sum of two cubes, the first factor will always be the sum of the cube roots. Okay, so again, the cube root of x to the third is x. This will be a plus. The cube root of y to the third will be a y. That's always going to be the first factor. Okay, if it's a difference, you only think this will be a minus. And then the second factor will be whatever this is squared. So this will be x squared. And then whatever this sign is here, it's a plus. This will be a minus. And then it's the product of these two terms. So this, in this case, will be xy. And then plus the second term, in this case, the y squared. Okay. So the factorization of this sum of cubes is x plus y is the first factor. And the second factor is x squared minus xy plus y squared. Okay, so there'll be some follow-ups on this to consider some other more complicated problems. But for now, this is the end of the video. Thanks for watching. We'll see you next time.